Hi, welcome to our session, Hands-on Python, Coding plus Physical Computing with CodeSpace and CodeBot. I'm David Ewing. I'm going to take you through this session today. It's going to be hands-on. We're going to have some fun, learn a little bit of Python programming, learn something about robotics, and learn a little bit about something called physical computing, something also known as the Internet of Things. So before we get started, we're going to go through just a couple of slides here to give you a background on what we're going to be doing and why, and then we'll get hands-on. So hopefully you'll have your CodeBot ready, and a laptop. Can be a PC or a Mac or a Chromebook. All of them work just great, and you'll be ready to get started. So first of all, I want to give you a little bit of background about something that I've been doing for a few years. I am an engineer, electrical engineer by training. I've done lots and lots of software programming over the years. So the last 10 years or so, I've been working in a field called the Internet of Things, or known as IoT. And that's a wave of computing that embeds software and computer control inside of a lot of types of applications that you wouldn't expect necessarily to see computers in. So it's really, it's the unexpected computing. So for instance, solar fields, out behind those panels, we've embedded computing devices that monitor the temperature of the panel, the current and voltage that's being produced by the sun. And also we do things like smart trackers that track and keep the panel pointed at the sun and things like that. There's applications like that nowadays are connected to the cloud so that the stakeholders in that field can monitor and manage what's going on at the field remotely and get better efficiency and better control out of it. Lighting applications, something that you kind of take for granted. You see lights in a department store or in a warehouse or something like that, or in an office building. Nowadays, since those lights oftentimes have been replaced by LED lights, they can be dimmed at a very kind of fine granularity of control. So you can get a lot of energy efficiency out of making that lighting application really tie into sensors so that you can have light sensors so that you can adjust the lights based on ambient sunlight coming in through windows or skylights. You can obviously use timers or motion sensors to do that, and or put them on schedules. A lot of things that we've always sort of thought about that could be done with lighting are being done now, and so those applications are really expanding. Food service, monitoring temperatures and things like that, that you think about, well, the health department's going to come look at your pieces of paper that say that you've checked the temperature so often. Well, a lot of that stuff that's still being done on paper is moving to automation. It's moving to being monitored by computers. So one of the cool things about this is for students, they're able to connect the dots between real applications in their world and programming languages like Python. Python is a computer programming language that's used in a lot of those sorts of applications we just talked about. It's one of the most popular languages out there. It's very popular in professional circles, but also in educational circles. So it's kind of cool. One of the neat things about Python is that it's a great learning language, but it also happens to be a language you can go get a job and make money in, which is actually a point that's not lost on a lot of our students. When I talk to especially our middle school and high school students and tell them that, hey, you can make a lot of money writing Python code, they get a little more interested. This is real world stuff, and it's very true. There's other languages out there, Java, C++, JavaScript, others you might have heard of. They all have their own niche where they fit, and some areas where they're probably the best choice. But there are also general purpose languages too. And Python's a great general purpose language. It's used for data science, machine learning on the cloud, but it can also be used on tiny little embedded devices, like on robotics, like the CodeBot that we're going to be talking about today. So it's a great language to learn. One of the neat things about physical computing and Internet of Things is it gives you the opportunity to connect the dots between stuff that your students will be interested in naturally and an area of technology. Whether you're interested in sports and want to put embedded microcontrollers and sensors inside of football helmets or shirts or wearables, interested in arts, if you want to make great displays of visual art, or in this case we have dance shoes shown here. We did an application where we monitored the tapping of tap shoes, and inside of each shoe was embedded a computer that sent the accelerometer data to a light show that happened in time with the dancing. Special effects for movies, musical instrument effects, and even smart agriculture is a great one. A lot of things are being transformed by the ability to put some intelligence inside of these applications. So being able to monitor more carefully and be able to act on that data and that information that's coming from those applications, like, essentially putting Fitbits on cows so that you can tell for an entire herd of cattle what's going on, what's the health of the cattle, are they, where are they, and things like that. Smart agriculture, also the precision farming, so that you can do a better job of dispensing the right kind of pest control, and even do organic farming using pheromones instead of using pesticides and things like that. But that's all hinged on being able to get more information about what type of bugs are attacking those crops and that sort of thing. So really great opportunities for tying in a lot of STEM type topics into things that students are going to be interested in. So that'll be another great tie-in as we go through the projects. When we looked at this from a company standpoint, like what can we do to help bring coding into the lives of more students, get more students jazzed about the computer science part of this? One of the things we noticed was that students they want real world authentic approaches, right? They especially by the time they're in middle school and high school, they know that professional programmers are using text-based languages. So we wanted to make a really great tool for doing text-based coding. And there is already some great stuff that do blocks, which is cool for introducing the concepts, but we feel like the students are ready to move up to being able to do text-based coding, and they need tools to be able to do that. So one of the things that professionals use all day long is debuggers, which give you the ability to step through the code. You can stop and step one line at a time and see what it's doing. And that kind of tool is not something we found in a lot of the educational environments out there. So we built it. We actually got an NSF grant that sponsored the research for Firia Labs to go off and build that technology, which is what you're going to be using today inside of CodeSpace. So marrying that technology with some really great curriculum that takes you through step-by-step project-based learning of coding concepts and of robotics applications like we'll be doing with CodeBot today is really kind of what makes CodeSpace so awesome. We've seen it in a lot of classrooms. These are some pictures of younger kids all the way through middle school. We've taken it with CodeBot all the way through 12th grade and even beyond. We've got colleges that are using the CodeBot to teach, electrical engineering topics and things like that. So it's a very versatile, very broad range of products that you can take in and really get your students excited about doing this. It really empowers them to go out on their own, especially with that debugger capability. They can write their own code, and you've taught them the troubleshooting skills to be able to debug it when it doesn't work, because the little secret is it usually doesn't work the first time you write the code. So you're going to have to debug it and troubleshoot it. It's a big part of what we try to teach. As you teach this, you're going to need some additional guidance, and when we first started this, I think it was the technologists in us pushing some really great tools into the education space. Well, we met a lot of great teachers who helped us prepare a lot of the things that we didn't already have in our minds, which is, pacing and sequencing guides, rubrics, standards alignments, all the things that you really need to make this a holistic curriculum to bring into your students. So we've got all that. Go to our firialabs.com site. There's a link for educator resources, and there's tons of stuff. A lot of them are available as Google Docs, so you can download them, you can remix them yourself. There's a lot of activities in there, even unplugged activities if you have a class that needs to start really from the basics. We don't assume they already know any Python or even had any coding experience at all prior to this. So we will start you from ground zero if you need it. And then the students can go, at whatever pace you feel like you need to be able to go with your class as you progress through the material. So given that background, we're ready to write some code. Grab your CodeBot and a laptop or whatever computer you're using, and let's surf on over to make.firialabs.com to get started. Okay, so head over to make.firialabs.com and you will be greeted with a sign in with Google button here. So click that sign in with Google and pick a Google account that you want to use. I'm going to use my personal Gmail You can use your school account or basically whichever Google account you want, but this is where your code is going to be saved. It's going to be saved to your Google Drive, and you're going to, it's also going to save your progress. So every student has their own individual progress and everything like that saved in their Google account. So you start out with a tour, because I've got a brand new account here, and we're going to find out what is in CodeSpace. So to the left-hand side is the editor panel. That's where you're going to type in your code. So this is text-based coding, so that's where your Python code is going to go. Next, there's a curriculum selector button at the top of the screen, and we'll be looking at this just in a little while because we need to select the Python with robots. Right now it's on free trial microbits. That's definitely not what we want, so we'll see that in a second. The right-hand side of your screen is mostly taken up by the tutorial lessons. So you'll see this Welcome to CodeSpace, and that's where your journey will begin. But all of the instructions here are pretty important. So try to take the time to read through them and encourage your students to do so. Most of the answers to the questions that they have will be there if they'll just read it. So there's some good lessons in reading also along with CodeSpace. So you do earn some experience points as you go. So as you pick up new coding knowledge and accomplish different things, you'll get experience points. The progress through the lessons is shown on the screen progress bar across the top. So you'll see as you make progress through each project, you'll see how far along you are. And also in the teacher dashboard, which we'll talk about here in a little bit, you can monitor the progress of all of your students and see where they are in the sequence. So the project menu will let you actually select different projects along the way. So you can actually sort of peek ahead or go back to projects you've completed before by dropping down that menu. And when you complete a project, there'll be a little green check mark right next to the name of the project. So that's something to watch out for. The toolbox actually collects tools that you learn about along the way. So things like this one here, debugging. You'll see a icon, a little wrench icon next to a blue word, and that's a place where we've put some additional content that's relevant to what you're doing, and you probably want to go in there and check it out because then it lands in your toolbox. That tool will always be available to you later in the course. Even once you're done with all of your with all the tutorial projects and you're just writing code on your own, you can always bring the toolbox back up and you can refer to things that you've learned. So right now this one's about debugging. It has a little picture of Admiral Grace Hopper's original moth that was discovered, or she discovered in one of the relays. So one of the original computer bugs. But the tools also refer to other tools. So I might want to look at control flow and learn about if statements. That's something we're going to be learning about here in just a little while. So you can always go back to these, and you'll see now I have 2 tools in my toolbox. So that's something that's good to encourage your students to do. All right, and then finally, at the end of every step of every project, there'll be a next button at the bottom of the screen, or a submit or complete, check your code button. So you want to do that so that you'll get credit for having completed that step. So when I do this, you can see, wait, before we look at the credit that we received, we need to select the actual curriculum. So this is going to pop up just this one time since I'm a new user and tell me, hey, do you really want to be on free trial microbit? Actually, no. Let's select Python with robots, but we have a problem. I only have 0 seats available. So we need to enter a share token or a license key. Now, as a teacher, you would go down here to manage licenses, click that, and then you can enter in your license key, which is this long string of letters and numbers. Probably you would just copy and paste that from an email that you received from Firia Labs when you purchased the product. But as a student, you're going to enter a share token. So let's all pretend like we're students right now. And when I'm a teacher and I've gone into the license manager, I can actually generate a share token. That's just a 2-word phrase. So it can be 2 random words. And then I can write that up on the whiteboard or send that to my students, and they will enter that in as their share token to share my license seats. So I've already generated a share token, and it's called Insofar Goosier. Okay. So we're going to validate that. That's my 2-word phrase that we're going to use for training today. So if you type that in, it should allow you to access my seats of Jumpstart Python and Python with Robots. So you see I've got all of my seats available, 100 of each. So we're going to select Python with Robots, make sure it's yellow there, and then we're going to say next, and we're going to say activate course. And that will actually bring up that Python with Robots curriculum for us to walk through today. And we're just going to get a little ways into it, but we're going to see how far we can get, and we're going to have some fun along the way, I hope. So we're back to the tour. We see I have not completed this step yet. So if I click next, I get some experience points for doing that. Then if I was to use this previous button and go back, you can see now I've got a little check mark by that step. I've completed that step. And I can either click next down here again, or I can just advance forward to the next step. Now, if I continue to advance, I can actually go forward into the curriculum, but I'm not getting credit for those steps. So that's just a little procedural thing. You need to always go down here. This step is just telling us about the legend for what the different icons you're going to see along the way. If I click next, now I've received credit for that step. Okay, so our first challenge is to learn a little bit about the CodeBot. So I've got my bot right here, and oops, I plugged it in. I was supposed to have it unplugged already. So I'm going to pretend like that didn't happen, and I can show you my CodeBot. Can look at it and go, it has outputs, it has inputs, lights and speakers and line sensors and stuff. Let's learn a little bit about that. So I'm going to click next. Now, we always warn the students, hey, this is a piece of electronic gear, and any electronic device can be damaged by static electricity. It's kind of rare that that would happen. I don't think we've had any CodeBots that were damaged this way, but all electronics are susceptible to that. And specifically on the CodeBot, we've left these chips open so that you can actually touch them. We want the students to touch them and see what this is made of, and tell them these are exactly the same sorts of components that are inside your cell phone or inside your computer or television. So these are real electronics. This is not toy stuff. And they're going to learn a lot about this electronics as they go along. So the first thing that they're learning about is static electricity. And let's see, we've got our first quiz. It's a formative assessment. Let's see if we can handle this. What should you do before handling your CodeBot? Well, clean it with wet wipes, of course. No. Oh, man. I lost an XP. I could have gotten 5, but now I can only get 4 if I can get this right. Yes, touch some grounded metal, like a light switch or a doorknob or something like that. That will get my static electricity zapped away before I touch the bot. So yay, got that one done. Click next, and now I'm to a screen that lets me actually hover over these little red tags, and I can find out, I can learn a little bit more about the parts on the CodeBot. So spend some time looking at these different parts and figuring out, what makes this thing tick. We're going to learn a lot about these as we go along. We're going to be writing Python code to explore those different peripherals. So you see I've got my central processing unit here. That's where the code is going to run. So in just a second here, when we download code onto the CodeBot, it's going into that little chip. So it's pretty cool. There's buttons, there's the USB connector, there's proximity sensors to let it see what's in front of it, or sense the distance to objects using infrared light. There is an infrared emitter for those proximity sensors. There's LEDs that you can light up to correspond to line sensors that we're going to learn about in a second. There's an accelerometer that can tell the CodeBot what orientation or if he's received an impact or vibration. All kinds of stuff we're going to be learning about along the way. So next, the bottom of the CodeBot. So be sure to look at the bottom of them. And there's the line sensors that are photoreflective sensors. So they send out a beam of infrared light, and they're sensing how bright it was when it came back. So your code can detect dark lines, bright lines, or anything in between. We'll be playing with those as well for doing line following, for doing obstacle avoidance and things like that. Wheel encoders are really cool. Wheel encoders are these little discs underneath that turn as the wheel turns, and we'll be able to count the pulses with our code, and we can see how far the CodeBot has moved. So they're really neat because they let you do precision motion with CodeBot. Really nice. But the cool part is it doesn't work automatically. You have to write code to make that work. So there's not a function that we give you out of the box that's like, go forward by 10 centimeters. Where would be the fun in that? We're going to make it so that you have to figure that out and write the code to be able to write that function, go forward 10 centimeters, by reading the wheel encoders and applying power to the motor until you've gone that far. The cool thing there is it gives you some really neat incentive to learn some Python coding along the way. And you learn how the CodeBot works. So it's like, fundamentals of robotics, computer science principles, all smashed together, courtesy of CodeBot. Okay, let's, without further ado, actually connect this thing to our PC. So we're going to use a USB cable, and we're going to connect into our CodeBot. And I gave you some foreshadowing of this a little bit earlier because I already had mine connected and I turned it on and off. So I'm going to plug it in, and you see I've got a little dialog box that popped up. We're not going to use the file system on this, so I'm going to close that. And basically, you are going to click Next. Mine, I've already connected it previously, so you can see my little USB connected icon up here is already black and it says it's connected. But on yours, if you click Connect USB, you'll see that may be gray, and you will have to, Chrome will pop up a little box that says make that FiriaLabs.com wants to connect, and you will have to click that. So since I clicked that button, I'm going to do the same thing. You'll have to click that button and tell Chrome it's allowed to connect, and then you'll see the icon turn black, and it'll mean that it is connected. All right. So next step, we're going to be writing some code over here, but we don't want it to be called Untitled Program. We want to name our file something meaningful. So in this case, we're going to call it Lights On, because the first thing we're going to do is try to turn some lights on. So you can name the file whatever you want, but we're naming this one Lights On. And now we're going to write some code. So before you start coding, uppercase, lowercase does matter. It's case sensitive in Python land. And punctuation is important too. Hey, there's another tool. Let's grab it. All right. So this is just going to tell us a little bit about those crazy punctuation marks and things like that. A little preview of what this import means. And we're going to go into more detail about that later when we learn about that. For now, kind of just trust us just this once. Most of the time in CodeSpace, we try to explain everything along the way because we don't want really to have any magic. Nothing's up our sleeves. We want to explain all the lines of code that we're writing, but just get these lights turned on to start out with. Let's see if we can do that simply without a lot of explanation ahead of time. So let's just do it. Here's the code from botcore import LEDs. Let's give that a try. So click over here in the text editor and type it in from botcore import LEDs. And then LEDs dot user num 0 true. Okay. All right. That ought to work. So let's see. Show us how to run the code. By the way, the user LEDs are those ones right down the center, and they're labeled byte actually, but we call them the user LEDs because they're made to be controlled by whatever the user wants them to be, or they represent whatever you want them to. So we'll talk a little bit later why they're called a byte. But first, let's figure out how to run this code. The run button here, it's a little triangle. It's a play button. So if we press that button, it will upload the code to the CodeBot and run it. So the code is actually going to run on that little CPU chip. The code is not running on your computer. So when you press run, it's going to transfer it over the USB to your CodeBot. Let's give it a shot. Oh, problem. Missing import at impot. Oh, typo. That was supposed to be import. Okay, thanks CodeSpace for telling me where that is. Click again. Runtime error line 1. Cannot import name LEDs. What's wrong with that? Oh, it's supposed to be all lowercase. Okay, all right. Lowercase LEDs. Let's try again. Run. Check capitalization of true. Name true is not defined. What's wrong with true? Capital O, it's capitalized. Okay, yes, in Python, the Boolean values true and false have to be capitalized. All right, now let's try. Go. Yes, I've got a red LED, so yay. You can see my little LED lit up there. Nice. That's LED number 0. They're numbered 0 through 7. You can see the numbers kind of go from right to left because they're numbering the binary position of that, the position of the digits. We'll talk about binary later as well. So we're seeing red, right? We're seeing byte LED 0 light up. I'm going to say yes. Sweet. We're programming Python. Proceed to the next project to continue your journey as a Python programmer. Let's do it. And here we go. So the next step is illuminate the code. All right. We get to find out what these lines of code actually do. and will be illuminated. So the first one, from bot core import LEDs. What does that mean? It tells Python to import the LEDs object from the bot core library. So what's import all about? Import is when you reference code from other code outside of the code that you're writing, right? So it's, in this case, code that's resident already inside of your microcontroller that's part of the CodeBot's MicroPython set of libraries. So import statements let you pull in things like music or random numbers or things like that. So these are some examples that aren't necessarily applying to the CodeBot. They're applying to the microbit. Random is available in the CodeBot, but microbit is not. So in particular languages and frameworks, you're going to find a set of libraries, and they will be useful for different things that you're trying to do. So in Python, those are called library modules, and that's what botcore is. So that's how we get those LEDs to play with, because Python itself doesn't really know anything about LEDs, but it knows about other modules. In fact, you can write your own modules, which is something you'll learn to do later on down the trail of Python with robots. So the second line of code here is actually doing something with the botcore module. So it's leds.usernum. And so that function, usernum, and these are called functions, they are bits of code that you can actually execute. So we're going to execute the usernum function, and it controls those user LEDs, those LEDs that are called byte LEDs across the center of the bot. And the num part of usernum stands for number. So it's saying number 0, and you can set it to a Boolean, true or false. So what's Boolean mean, right? Boolean, it means a true or false literal value. It's named after a famous Englishman, George Boole, back in the 1800s, invented this thing called Boolean algebra, a whole system of logic and operations, mathematical operations on true and false values, or ones and zeros. So it's very much tied in with the way in computer land to the binary system and how computers work fundamentally. So as a matter of fact, if you look down through this tool, you can wind your way into an explanation of binary numbers. So in this case, though, there's 7 user LEDs numbered 0 through 7, and we can set them to true or false. So those binary values, true or false. So let's play around a little bit more with the red user LEDs, and then there's also some green LEDs that are the line sensor LEDs. They work in a very similar way. You can say leds.lsnum. So I'm going to try setting a couple more LEDs. So I can use copy and paste. If I select this line, Control C, Control V, I'm going to try usernum 0. Let's try 1 and 7. There's three of them on. Let's just see if those light up. Ah, there we go. I've got 0, 1, and 7 on. Nice. Okay. Let's try lsnum. So leds.lsnum, line sensor LEDs. These actually, they don't do anything about sensing lines. They're just LEDs that are aligned above the line sensors. So there's a future project where you're going to make the LEDs light up corresponding to where the line is on the line sensors. So that's the reason those LEDs are in the position they're in, but they're fully under control of your Python code, so you can do whatever you want to with them. So in this case, if I say line sensor LED number 0, I can set it to true, means on, and then the last one is 4. So it's 0, 1, 2, 3, and 4. So let's try getting these outside 2 line sensor LEDs lit up. If we can get it to a position where you can actually see it without too much glare. All right, let's try that. Go. All right, you can see they lit up there. A little bit too much light in here for you to see those clearly, but try it yourself and you'll see 0 and 4 light up. So very nice. Next. Great, that's our first project. So we've completed our first little bits of lighting up things and learning how to control parts of the CodeBot. And next step will be the next project. If you were using Google Classroom, this would be a time when the students could turn it in with Google Classroom. So real quickly, just to show you how that works, as a teacher, I can go into the Help menu here and click Add Student Assignments. And what that will do is it'll let me choose a class that I'm teaching I can choose this class, and then I can add all of the CodeBot Python with Robot curriculum projects into my classroom as assignments. And they'll go in as draft assignments. Then as a student, when I'm done, once I've completed all the steps, I can turn it in. I can pick a classroom that I'm enrolled in and then turn that assignment in. So that's what that's all about. There's one more thing while I'm talking about sort of teacher resources there. If you go into that help menu, the teacher dashboard. So a student can join your class that you've created for the teacher dashboard. It's a completely separate thing than Google Classroom. So you don't have to be using Google Classroom to use the teacher dashboard or vice versa. But if you click on teacher dashboard, this will give you a place to, you can create a class code, you can create a new classroom and give your students that class code. When they join, you can now see all of their progress, whether they're in Python with Robots or Jumpstart Python. You can see all their progress, where they are as they complete each project. So that's just something to know, and that's also available on the help menu there. And if you go into our teacher resources at firialabs.com, there's documents that sort of describe how to use those things and give you some more screenshots and things like that. So for now, let's click next and go to the next project, time and motion. All right, this one's really exciting because this is where we're going to get our CodeBot moving. So we're doing physical computing. We're already lighting things up. We're already controlling a device. And we're going to be able to use timing to be able to basically choreograph movements. So a lot of the basic robotics things that you see being done are done with timers. So doing a particular operation like moving a motor for a particular amount of time will move the robot from one position to another. So that's one of the first things we're going to go do. We also can do that with lights, right? If we move, if we change the LEDs, like we showed how we could light up multiple LEDs, but if we change that with a time delay, then we can animate those lights and make the lights do interesting things. So our goals are flash the LEDs in a controlled sequence, make a light show, learn how to use the debugger. That's a really important part of learning how to code with CodeSpace, is learning how to step through your code and see what it's doing when maybe it's not doing exactly what you thought it should do, which is a lot of the time, right? And then we're going to power up the motors, move our bots around, and we're going to even use the push buttons and learn about push button input. So we're going to do some inputs as well as outputs. All right, let's get coding. Okay, first, we're going to talk about sequencing the LEDs. So we've already played around with the user and LS line sensor LEDs. Now let's see if we can make them do something cool. Let's make the user lights turn on in an animated sequence. So here they are, the user lights. If we make them go, I don't know, 0, 1, 2, 3 like that, just sweeping across in an awesome little array of LED fireworks. So let's try that. We've already got part of the code written here, so I'm just going to erase these, and I'm going to change this to 0, 1, 2, and one more, 3. Okay, I was supposed to name this, create a new file and name it sequence LEDs. So, I'm just going to change the one that I've already got. But you can always do this. You can say new file, and it will give you a brand new file, and it will save the one that you were working on before, so you can come back to them. So you can always go. I mentioned to you that these are all stored in Google Drive. You can always go to your Google Drive and see previous files that you've worked on. So anyway, in this case, I'm just going to replace the one I've got with sequence LEDs. All right, so here's my sequence, and let's run it. Let's see what happens. So right now it's showing that go. It lit all 4 of them up. Okay. I did not see them turn on in sequence. Did you? No, it looked like they turned on at exactly the same time. Well, we got 4 LEDs shining, so that's good. But what about one at a time? Well, first of all, let's see what's really happening here. Are they all turning on individually and just going so fast that we can't detect it? Or does CodeBot somehow just decide to, I don't know, run all this at the same time or something? So even a small CPU like CodeBot goes really, really fast. It executes those lines of code really, really fast. With the debugger, you can step through one line at a time. You can stop on each line and see what's going on. And the way we do that is by clicking this step button. So we'll let it show us how to do it. When we click step, it's going to load the code onto your CodeBot. So it's going to transfer your code onto the hardware. And then it's going to wait at the first line of code. And it's going to have a red box around the first line of code that it's going to execute. And then when you click step again, it will run that line of code, which happens like that. And then it's going to stop on the next line. So you're always going to see a line with a red box around it, which is the next line that it's going to run when you click step. So let's try that. All right, so if we hit step, okay, it loaded the code. And then and nothing changed. If I hit step again, all right, now it cleared all the LEDs because it executed that import statement, which really does nothing. Hit step again, aha. It ran this first line of code. num0 is true. So now I hit step again. It did the next one. Now it's going to light up number 2. And now it's going to light up number 3. And my program ended. So by stepping through the code, I could see that they did really all light up in sequence. But it must have just happened so fast when I hit run and it ran all at once that it looked like they came on instantaneously. So how are we going to slow them down? Well, there's a handy little function called sleep in another library called time. So let's grab that time module and say from the time module, I want to import a function called sleep. Okay. And then, by the way, you can put blank lines in your code if you want to. That kind of helps break things up sometimes. So we're going to say sleep 1.0. It's in seconds, so we're going to do exactly 1 second. That should give us plenty of time to see. I'm going to copy and paste to see the LED. So now I've copied and pasted that 3 times. So now I'm going to display, I'm going to light up 0, I'm going to wait a second, light up 1, wait a second, 2, and then 3. All right, let's see if that works. See, we'll run it. Here we go. Nice. All 4 in a row. Very nice. Notice the sleep only has to be imported once. And normally we put our imports at the top of a file. And then I put a sleep statement for 1 second after each line of code, after each LED change. And I didn't need to put one at the end of the program. Why? Well, when the program ends, the lights are all still lit up. Right, so there's no point in sleeping because the program is, when Python runs off the end of the screen basically here, it just stops. And that's why you can see it says program ended at the end of this. So it's stepping through, and then program ended. Okay. Yes, we saw all the LEDs light in sequence. All right, steady as she goes. Okay, so that's pretty cool, but why don't we try a different value? I want to see them go faster. Maybe I want to see them go not 1 second, but half a second, or maybe 1/10 of a second. Well, now I've got to go change everywhere that I've got to sleep. I've got to change that number. So wouldn't it be nice to just have that delay one place, just in one spot in the code? Well, it turns out you can do that. You can create what's called a variable. A variable is like a box with a label on it. It's like a little name that I can put whatever value I want into it. So in this case, I'm going to make a variable called delay. And I'm going to stick the number 1 for 1 second in there. And then later, if I want to, then I can use that name delay anywhere I want to in the code. Later, if I want to change it to 2 seconds or to ½ a second, I just change that in one place where I define the variable. So if we define it, we have to define it before we use it. So sort of up at the top of the code here, we can put delay equals 1 or 1.0 in this case. And then everywhere where we had sleep 1.0, we can just change it to sleep delay. So notice how it's showing us the new code we're supposed to put in, but it's kind of blurring out the rest of it. That's a little hint that CodeSpace gives you about here's the code that you need to change from the example that you had before. And it also, we use that blurring to provide the students a little bit of incentive sometimes to remember things in their code to give them, to force them to use their memories a little bit. So let's go ahead and do this. Delay equals 1.0. So now we've defined the delay, and now I can just replace everywhere that I have 1.0 with the word delay. All right, so now if I run with delay equals 1.0, it's going to basically do the same thing it did before. So 1 second delay. But I can now change and make it, how about 0.2 of a second? Delay equals 0.2. Let's see what that looks like. Much faster. How about 0.05? 50 milliseconds. All right, you can see it sweep on across. So that shows you can do some animation, and you can have little small delays in between LED changes. Very cool. Got your variable working? Yes, we do. A powerful tool in our coding toolkit. It is. All right. So now let's use those fancy LED capabilities and make our CodeBot do something really cool. We can make, on-off flashing displays, and we can make, fancy Knight Rider effects. There's all kinds of things we can do with this. So if we modify our code to make the LEDs turn on and off, that means we've got to turn them back off. That means instead of true, we've got to set it back to false. So if we turn, in this case, an LED 0 to true, we delay, turn it back to false. Ah, I see what's going on here. Can you see it? LED 0 lights up, delay, turns off. Now all of a sudden LED 1 turns on, delay, and it goes back off, and then 2 comes on. So we're going to step the LED right down the line. So let's see if we can do that. So first, I light up number 0, I delay. Now I need to turn off 0, so I'm going to copy that line of code and then change it to false. Okay, so now I've turned off 0 just before I turned on number 1. So we'll just copy that. Now I'm going to turn off number 1 before I turn on number 2, and turn off number 2 before I turn on number 3. All right, let's try that. Let's see if that steps the LED right down the path. Okay, here we go. Oh yeah, mine's still going really fast. So let's change it to maybe 0.2 so we can really see what's going on here. Okay, so the LED looks like it's moving. It's a better animation effect. Hey, that's like 1/4 of a Knight Rider sweeping back and forth, or a Cylon effect, depending on what your television preferences from the 70s were, I guess. Okay, can we make it flashier? Add more LEDs? Hey, why not even add the line sensors to the party? We can do that. Those LEDs, or the green LEDs, could be moving the opposite direction from the red LEDs. So there's a lot you could do with this. I'll leave that as an exercise to the reader, but you can see you can really make them pretty flashy. So do we have a dazzling light show? I think it's pretty dazzling. All right, brilliant. Okay, so we've been playing with this byte thing, right? This byte LED. And it is interesting, but it's kind of a pain. Every time we change an LED, we have to give it, the number of the LED and stuff. Wouldn't it be great to be able to change all of those lights at once with a single call? Well, it turns out that you can, and we're going to show you how. The 8 LEDs are arranged as bits in a byte. So 8 bits of binary data is called a byte in computer science. And as promised, there's a tool here for binary. It's how computers deal with digits. So I'm not going to go through all of the description here, but basically in an 8-bit binary number, you can have 256 values. So you can count from 0 to 255. So all of them lit up, all 8 LEDs lit up would represent the number 255. None of them lit up represents the number 0. And so you can, for instance, represent any number you want. Here's the number 9. You can use Python literally to set those binary values, and there is actually an API, an application programming interface for CodeBot LEDs that let you express their value in binary. So let's show you what that means here. Instead of saying user num or ls num, or we're actually bringing out another one of the CodeBot LEDs, there's the proximity sensors too. They have LEDs, so there's the line sensors, and then there's proximity sensors. Instead of saying user num, you can say, or ls num, you can just say leds.user or leds.ls, and you can give that function a number. And the nice way to do it is to prefix that number with 0b, and that 0b prefix means it's a binary number. So I can completely control these LEDs using binary. Let's make a new file. So this time I'm going to follow instructions. I'm going to say File New, and I'm going to make a program called Binary LEDs. Okay, so now I'll still do the from botcore import LEDs. And then I'm going to go ahead and import time, because we'll need to do some timing here. From time import sleep. Now I can say LEDs.ls. Let's just try this. 0b for binary, 00100. Let's try just that. So what's that going to do? 00100. Well, if you look at the line sensors, there's 5 of them. And so the very center one, if I go 00100, and actually I did that backwards, starts over here. So you start counting from that side, 0000100, like that. So that binary value should correspond to the LED pattern we'll see. And it does. Try it yourself. So I can control those LEDs all in one line of code. So if I were to say 11111, 5 ones, that should light all of those LEDs up, all those line sensor LEDs. And indeed it does. How about the user LEDs? Can I control them the same way? LEDs.user 0b 1111 1111. Let's give it a try. Be a simple way to light up all those LEDs. Wow, nice and bright. Okay, works great. Hey, why don't we add another one? What's going to happen? Well, LED was out of bounds. So that means you can't give it a bigger number than what it can display. So that's okay. That's okay. It turns out you can actually, I mentioned to you that all ones was the number 255. So if I was to put a decimal 255, it does the same thing, right? Or 254, I don't know. So that shows you can count, you can actually learn binary by giving different decimal numbers to the CodeBot and looking at those user LEDs and figuring out translating between decimal and binary. So it's pretty cool. All right, so this is a program that's going to make an interesting sequence. It's going to light the middle line sensor LED, sleep a bit, and then light up the middle 3, sleep a bit, and then all 5. All right, let's give that a try. Just because we're being compliant users here. So we've already got part of it written for us. So we'll replace the last with 0. We're kind of writing it backwards, aren't we? Okay, so now we've got, now that's going to happen really fast. So I know I'm not going to fall for that again. Let's sleep for half a second in between these. And if you want to, you can create a variable, but we'll just do it this way. And let's see if we can see our line sensor LEDs do something cool. Yeah, you can see them expanding out. So it's kind of a neat effect there. Yeah, my LEDs are getting their binary on. I hope yours are too. Nice. Okay, now it's time for another formative assessment. Let's see how we're doing. Controlling the LEDs, that's hello world of the embedded programming industry. When you get a new piece of hardware, a new device, you got to blink the LEDs. That's the first thing. That way you know once you can blink an LED, you can do anything. But you got to get those LEDs blinking first. So why would we add a delay, a sleep after we turn on each LED? So we'll turn on? No. So you can see them turn on one at a time, because otherwise they look like they all come on at the same time. Yes. When you use the debugger, the line of code with the red outline ran the last time you press step. We'll stop the program. No. We'll run the next time you press step. Yes, that's it. Is currently running? No. When the debugger is stopped, nothing is running. Your code is not running until you click step. But when you click step, that line that you're stopped on, that's the next one that's going to run. So yes, that's it. All right, the statement sleep 1.5 pauses the program for 1.5 milliseconds. Nope, not milliseconds. No, pauses for 1.5 seconds. So sleep from the standard time library is in seconds. All right. All right, what does from time import sleep do? Allows the code to read the current time. Not really. Gives this code access to the sleep function from the time library. Yes, that's what it does. Which LED does the following turn on? LEDs.ls. All right, so it's the line sensor LEDs 00100. Well, it's the middle one, which if I look at my CodeBot, it's 012. It's line sensor LED 2. All right, you always start counting at 0 in Python, so line sensor LED 2 is it. Nice, we aced it. Awesome. All right, now it's time to get moving. The moment we've been waiting for. Let's get those motors cranked up. So back in the back of CodeBot, you've got these little nicely protected motors. You can see what the inside of that little gearbox looks like here. And make sure you've got batteries loaded because you're going to want to be able to unplug to watch the bot move around. When you're using the motors, there's a little power switch, as you've seen. You need to switch it over to BAT so that you know you're able to go unplugged. And sometimes, also when you're connected to even if you're connected to USB, if you've got that switch to BAT, the motors get their power from the batteries. So they can run from your USB port, but some laptops have a hard time powering the motors. Most of them, actually, it's not a problem. So give it a try and see what you think. You will need a little bit of space, and be careful not to press run and have your CodeBot run off your desk. So not that that's ever happened to me, but maybe. All right, let's make a new file this time and call it move out, because it's going to be time to move out. Move out. Okay. We're going to start slowly by powering one of the motors at 50%. So we have to call this function enable true first. Actually, if I click on the motors tool help, I don't think I've gotten that yet. It actually tells us everything we need to know about moving the motors. 0%, you basically give them a percentage. 0% means 0 power, so they're going to stop. 100% means turn forward at maximum power, and negative 100% is reverse at maximum power. So we can go full speed forward, full speed reverse, and everything in between. So that's, and well, not really everything. You need to pass, those are round numbers, so integers is what gets passed to those motor speeds. So let's give that a shot. We have to call the enable function, so motors.enable to true, and then we can run the motors. So our code is going to look like this. Now notice, instead of doing from bot core import LEDs, in this case we're going to do import star, which means we want all of the functions from the bot core library, and that's called a wildcard, that star. So let's just do that. That way we'll get motors, LEDs, and anything else we want. It's just going to make it a little less typing for us to do our experimentation here. All right, import star, and then we're still going to need some timing from time import sleep. All right, so motors.enable true. All right, so that actually allows the motors to run, and then motors.run, and you give it left or right, and the directions are defined also. Left and right are defined in bot core. So left, we're going to say 50%. We're not even going to turn on the right motor right now. All right, we're going to sleep for just a little bit, 1 second, and then we're going to turn the motors back off. False. Which is kind of good practice to do. Although when your program ends, CodeSpace, actually the Python implementation on CodeBot, is going to automatically disable the motors when your program ends. Or even if your program hits an error and ends because of an error, we don't want it to keep running, so it will turn them off for you. But let's see what happens. If we didn't sleep, your program would end and the motors would automatically go off and you wouldn't really see much. So this is the left-hand side. The motors are labeled left and right here. So let's see if we can watch that left-hand motor turn. Nice. So it works. We got motion. All right. If you unplug, set it down, you can watch it rotates a little bit when it's when that one wheel is turning. So very nice. You can make it turn farther by increasing the amount of sleep time, or you can experiment with various power levels. So more power, obviously, it's going to be turning a little farther. Try positive and negative powers. So do a little experimentation on your own. Each time you make a change, you can unplug your CodeBot, let it run on batteries, plug it back in, make a change to the code, and try again. So experiment and see what you think with that. See if you can learn a little bit about how the motors work. Okay, so you know I have to try it. So, all right, we're unplugging. And I've got my handy board. I recommend these corrugated sign boards. All right, turn my bot right here so you can see it. All right, get ready for your close-up, Mr. Bot. And then I'm going to turn the switch to battery. Whoa. And there he went for 1 second. If I hit, I can hit the reboot button on the bot, and he will go again. My program will run again. So you can see it's kind of rotating around. Since the right wheel is not turning, it's kind of pivoting around the right wheel. Nice. Okay. That's pretty simple. Little simple bit of code there. Let's see what the next step has in store for us. And yes, we're moving now. Yeah, we've turned a corner. That's right. All right. Last thing we're going to do in this sequence for this session today is I'm going to show you rotation. You might have already figured this out. If you use both motors, you can make the CodeBot rotate and stay right in the same place. Just rotate on its center axis. To do that, you have to run both wheels at the same speed, but one of them has to go in reverse. So pretty easy. We're already running in the code that I have the left motor 50% forward. So to run the right motor at 50% backward, that's just copying that line of code, making it right, and do -50. All right, check it out. There's comments in my code. So with this little hashtag or #, depending on how old you are, you can put a comment in your code. Everything after the hashtag is ignored by the computer. It doesn't even care. It's just for humans. So here's a whole write-up on comments and really the philosophy that you want to think about when you're writing comments. As you comment your code, think about you're making notes to yourself. When you read this code later, you're going to want to explain to yourself what you were doing over here. So there's a lot of reasons why comments are a good idea. And these are the hashtag to the end of the line. So let's do this program though. We are already running the left 50%. So really all we have to do, I can skip the comments for you guys and just say motors.run right -50. Okay, so that will make the left motor go forward, the right motor go backward, and I should get a nice little rotation there. And just for fun, let's put one comment in here. We'll say rotate. Which direction are we going to rotate? Let's see. If the left is moving forward and the right's moving backwards, if I'm looking downward on the CodeBot, that would be a clockwise rotation. So I'm going to say clockwise. All right, we'll prove out if that really is what happens here. All right, so first I've got to load this code in. I'm going to hold the CodeBot up in the air while I run the code the first time. And it kind of looked like it was working. Seeing the wheels move in different directions. All right, but the true test is to run it on my board. All right, here we go. I'm going to put him straight forward there. I'm going to hit reboot. Hey, I've got a clockwise rotation. Very nice. All right, and that's 50% power, so you can go a lot. You can spin a lot faster. So you can try different speeds. You can try different durations and check out your rotate action. So you've already done this part. I'm whirling like a top, or maybe it's a ballet bot. It's a gyro bot. All right, I'm going to let you guys do this challenge on your own. This is your first navigation challenge, the first of many, because there are other navigational aids within CodeBot. This one's just using time and motion. It's just using choreographed movements. So you're not using sensors yet to navigate, but you're going to program the CodeBot to drive in a square. All right, so this is going to require an algorithm. This is going to require you to do a series of steps to get to your solution. And so the algorithm will be something like this. Enable the motors. Now drive forward for 1 foot. How do you go forward? Well, both wheels moving exactly the same speed should make you go forward, right? So go forward 1 foot. You're going to have to adjust your timing or your speed to make that happen, right? And once you go forward 1 foot, turn right by 90 degrees. Well, you just saw the code that I have here on the screen. It's turning right clockwise, but it's turning right a lot more than 90 degrees, right? It's turning almost, well, maybe more than 360 degrees all the way around and more. So you're going to have to adjust again your speed and your duration to get that right turn. And then basically you're repeating those steps. Forward a foot, right 90, one more time, and one more time, and now I've made our complete square back to where I started. Then you can disable the motors and you're done. So that's your algorithm. So now you just have to write the code to make that happen. All right, not too complicated. Some of you who might have done coding in the past might be thinking, well, this is a lot of repetition. Surely Python has a way to do looping and things like that. Don't worry, we'll get there. Of course it does. But to start out with, we'll keep it simple. You can do a lot with just timing and sequencing. So one of the neat things here, and if you are a more advanced programmer, you'll be thinking about making your own functions to do that and move forward and turn right and things like that. So we can divide and conquer all of those steps. So dividing up that algorithm or those steps that we're about to do into small chunks, like let's just figure out how to make it turn right. Try that, just turning 90 degrees. Let's get that piece of code done first, or let's just do the move forward by a foot. And then once you've got those things working, now you can piece together the entire algorithm. That's a really great, divide and conquer is a great tool. I like that Bjarne Stroustrup, the creator of C++, you made this comment in his one of his main textbooks on the language, and I always thought it struck me as amazing because really there's only one way of dealing with complexity? But he's kind of right, and it's pretty amazing. So it's amazing what you can build when you layer on top of code you've already written. Okay, so make you a new file called navsquare and go for it. I'm going to leave this with you guys. I know we've already been through a lot today, and there's a lot more that you'll be going through, but you can do this on your own. We are not yet all squared away. I will show you kind of a preview of what you're going to be doing next. You're going to be using the CodeBot buttons. So once you've got that square going, you're going to be able to make a choice about whether you're turning right or turning left and things like that. So there's a lot more interesting stuff that you can do with just time and motion and a little bit of input. The next projects, the animatronics project is really awesome. It sends you on your own journey for creating a real application that would be used in a theme park. So it's a really cool setup and a really neat challenge. Fence Patrol is where you start learning about the line sensors. How do you actually sense something that dynamically as the CodeBot moves? So it's autonomously, basically reasoning about its environment based on the sensors that it has. So now you're really talking about autonomous robots. And once you've done that, you'll be able to do the next project, which is the line following, actually making it follow a course, and so forth. So I'm not going to spoil it all for you. You can go explore that on your own. But by all means, feel free to give us a yell if you have any questions or comments. You can always reach us here at info@firialabs.com. And once again, I really appreciate your time and hope you enjoy Python with robots.